Today we're going to be learning how to write polynomial functions given some information. So let's start off with number 1. This is telling us that we have a graph, a cubic, with roots at -3 or -4, -3, and 1. So we know our roots are -4, -3, and 1. So we're going to start off with this information and write our form for this function. So if your roots are -4, -3, and 1, our graph is going to take the form of f of x equals, we're going to put an a because we don't know what the leading coefficient is, but we do know the factors. Right? So because it's a -4 here, we know that our function should have a factor of x plus 4, because when we solve that, it's going to give us a root of -4. It should have an x minus 3, or x plus 3, and also an x minus 1. So because of these three roots, we can write our factors, they're always the opposite sign. So if it's negative, now it's positive. So this is what we're going to start off with. From here, our next piece of information is that we have the point -1, 12 on the graph. So they're giving us here an x and a y. That just like what we did for our quadratics, we're going to take these two numbers and plug it in so that we can solve for our a. So our y is 12, so we're going to put 12 in place of the f of x because that's our y. And then every single time we see x, we're going to substitute -1. So we're going to put -1 in place of this x, in place of this x, and then in place of this x. After that, we're just going to simplify because we're trying to solve for a. So we have 12 equals a times -1 plus 4 gives me 3. -1 plus 3, which gives me 2. -1 minus 1, which gives me -2. And now we're going to multiply all of these together. So 3 times 2 is 6. 6 times -2 gives me -12. Now if we're trying to solve for a, we're getting a by itself, so we need to get rid of the -12. They're being multiplied, so the opposite of that is dividing. So we're going to divide both sides by -12, so this cancels out. We're left with a equals 12 divided by -12, which is -1. And now that we have our a, our answer is just going to be plugging our number in for a back in our original equation. So our final answer, f of x equals, we have -1, which is your a, x plus 4 times x plus 3 times x minus 1. And because we want this function in factored form, here are all the factors. This is it. This is your final answer for the equation. And because it's a 1, you don't necessarily need to have the 1 there. You could just have the negative sign. Now we're going to sketch this. So this is the same thing we just did yesterday. Let's first look at our roots. We have 3 roots, so it's a degree of 3, which tells us it is odd because 3 is an odd number. We just solved for a, so we're going to look at the beginning here. This is negative, so we know it's a negative function. So we could not have sketched this without solving for a because we wouldn't know if it was negative or positive. So if it's odd and negative, we know it's going to look like the cubic function but reflected across the x-axis. So on the left side should be pointing up, the right side should be pointing down. Okay, let's plot our points. We have 2, 3, -4, -3, and 1. So we know we want on the left side it to start up at the top. And because all 3 of these are single roots, there's only one of them, we're going to go straight through all of them, and it's going to look like that. And we are done with number 1. So this is factored form, and then the graph, which is what we did yesterday. Okay, let's do number 2 now. I'm a cubic with a double root at -4 and a root at 0. So let's start off with our roots again. We have a double root, so I'm going to write -4 2 times, and a root at 0. And again, they're going to give us another point. This time we're going to write the function in a polynomial form, which I'm going to show you what that looks like. And we're going to sketch it again. So let's start off with writing our function in terms of the roots. So we know we have f of x equals a. The minus 4 turns into an x plus 4. Because there's 2 of them, we're going to put a squared here to show that there's 2 x plus 4s. For the 0, really what we have here is x minus 0, but minus 0 doesn't mean anything, so you don't need to write that there. You can just put x. So x is going to be giving us a root of 0. Okay, just like before, we have an x and a y from our point to negative 36. This is my x and my y, so I'm going to plug those in. So my y value goes in place of the f of x. So this is negative 36 equals a. And I'm plugging in for x, 2. And again, we're going to solve for a. So once we simplify this, what we need to do first is what's inside the parentheses. So 2 plus 4 gives us 6. We're going to square the 6. So 6 squared gives us 36. 36 times 2 gives me 72. Again, we're solving for a, so we got to get a by itself. How do you get rid of the 72? Divide. So a is equal to negative 36 over 72, which we can simplify to be negative 1/2. And again, we're just going to take this value for a, plug it back into our original equation. So we have negative 1/2 x plus 4 squared times x. And so this is where we would stop if this was asking for factored form. Because they're asking for polynomial form, what we're going to do is multiply this out. We're not going to leave it like this, we're going to multiply it out. So the first thing I want to multiply out, just like with our PEMDAS, we're going to first square this before we multiply it with this one. So what we need to do is square x plus 4. So we're going to multiply x plus 4 times x plus 4. I'm just going to do it off to the side. This is FOIL. So this gives us x squared plus 4x plus 4x plus 16, which we can combine like terms and give us x squared plus 8x plus 16. And so here we have the negative 1/2, and we also have this x. I'm just going to bring this x up here, multiplied by this. This is what x plus 4 squared is. So x squared plus 8x plus 16. And again, we want to distribute as much as possible. We want to multiply it out. So I'm going to distribute now this negative 1/2 x to all three of these. So negative 1/2 x times x squared is negative 1/2 x cubed. Negative 1/2 x times 8x. So negative 1/2 times 8 gives me negative 4. X times x is x squared. Negative 1/2 times 16. So half of 16 is 8. So negative 8. And then there's 1x left over. And so this is now my fully multiplied out polynomial form for this function. So this is the polynomial form, whereas this one was the factored one. So most of the time I'm going to ask you for the factored one, but once in a while when it isn't too hard, I'm going to ask you for the polynomial form. Okay, let's again go back and sketch this very quickly. So we have 1, 2, 3, degree of 3, it's odd. It is, let's look at our final answer, it is a negative. You see how there's a negative in front of both of them. So odd and negative means it's cubic, reflection across the x. So this time my points are at 1, 2, 3, negative 4 and 0. Being careful that my negative 4 is a double root. So this is a double root. So what this looks like, again on the left side it starts up at the top, so I know it's going to start up here. Because this is a double root, I want it to bounce off, so it looks like the quadratic function. It's going to bounce off and then go straight through my single root, so that it ends up pointing down, just like my sketch predicted. And that's my sketch for number 2. Okay, let's do 3 and 4 now. So these two are a little bit simpler because this time we're starting off with the sketch. So let's look at number 3. We start off with the sketch. All we need to do is write the equation for each of these. So let's start off with the sketch. What we need to do here is identify our roots from this sketch. So here are my roots. 1, 2, 3. My first root is, this is -1, -2. I have a root at -3. This is a single root because it goes straight through. This root is at 1, 2, but what type of root is this? It bounces off, so this is a double. So when I write it down, I should have 2 roots of 2, and then I have 4, another single root at 4, because it goes straight through. So once I have this, everything else is the same as what we just did. So I have f of x equals a. Let's turn this into an equation. So if it was a -3, now I have x plus 3 as my factor. The 2 2's mean that I'm going to have x minus 2 squared, right? Because there's 2 of them, so I'm going to have a squared there. And then the 4 gives me x minus 4 because I changed the signs of all of them. After this, again, I have my point. This is my x, this is my y. This is what I'm going to plug in to solve for a. So my y value is -24. My x value is -2. So every time I see x, I'm going to plug in -2. And then I'm going to simplify. So I have -24 equals a. -2 plus 3 gives me +1. -2 minus 2 gives me -4. I'm going to still square that. The -2 minus 4 gives me -6. So I'm going to first square my -4. -4 times a -4 gives me a +16. And now I'm going to have to multiply these together. So 1 times 16 gives me 16. 16 times 6 is going to give me 96, and because it's a negative, it's going to become negative. So I have -24 equals a times -96. And again, to get a by itself, I'm going to divide by -96. And I get a equals -24 over -96. The negatives cancel out, so I'm left with 24 over 96. And this can actually be simplified. So let's see, if we divide them both by 2, it's the same thing as 12 over, let's do 96 divided by 2, 48. And then both of those can be divided by 12, and it'll give me 1 over 4. So my a value is just 1/4. And now all I have to do is plug this back into my original equation. So I have 1/4 x plus 3, x minus 2 squared, x minus 4, and they want it in factored form, so this is my final answer, and I am done. Okay, let's do number 4. Again, it's a graph, so we're going to start off by looking at the roots. Okay, so our first root is at -1, -2, -3. This is -4, but look what type of root this is. It curves through it, so this is not a single root, it's a triple root. So I'm going to have 3 -4's, and then I have a single root at 1. Okay, so let's write this as a equation. So if f of x equals a, the -4 turns into x plus 4. Because it's a triple root, there's 3 of them, I'm going to cube the x plus 4. And then the 1 becomes a x minus 1 for my factor. And just like my other problems now, I need a point xy. There's my x, there's my y. I'm going to plug it in so I can solve for a. So I have -162 is my y value. For x, I'm going to plug in -1 for both my x's. So I have -162 equals a. -1 plus 4 gives me 3. Still got the cubed. -1 minus 1 gives me -2. So -162 equals a times 3 cubed So 3 times 3 times 3 is 27. And then we still have that negative 2. So let's multiply 27 times 2. 27 times negative 2 gives me negative 54. Again, I'm going to solve for a by dividing both sides by negative 54, which leaves me with 162 divided by 54, which again we can simplify. So let's say we divide it by 2. That'll give us 81 over 27. Both of those are divisible by 9. So this could be 81 divided by 9 gives me 9. 27 divided by 9 gives me 3. Okay, what's 9 divided by 3? Your A value is just 3. So you can do this pretty complicated division problem without a calculator. And my final answer, I'm just going to take that A, plug it back into my original function. So I have x plus 4 cubed, x minus 1. And again, because it's factored form, that's all I need to do. That's my final answer.